Hello. So here we are studying about the structure and working of photodiode in solar cell. Photodiode. Photodiode is a special type of PN junction diode, or it's a PN junction diode. When it is exposed to light, it produces current due to photoelectric effect. It is also known as photodetector or photosensor. It operates on the reverse bias mode due to since we are the current is produced using the minority charge carriers, and it converts light energy into electrical energy. These diodes have a slow response time. As we know, photoelectric effect is a slow process, and thus when we increase the surface area, more radiation is incident on the diode. It has a faster response time and faster current is produced. And it is alike to the normal PN semiconductor diode. Principle behind photodiode is photoelectric effect, which is when photon with an ample energy strikes a surface, the electrons are removed and produces this procedure is known as photoelectric effect. Operating principle of photodiode is such that when junction with two terminal semiconductor device is emulated, then the electric current starts flowing through it. Only minority current flows through the device when the certain reverse potential is applied to it. Here we can see a photodiode which is similar to light emitting diode. The longer side is the anode terminal, shorter side is cathode terminal. Types of photodiode: it has PN, normal PN junction diode when radiation is applied to it. PIN is an intrinsic highly injected PN junction diode, and does it produce more current. And another is Schottky photodiode and avalanche photodiode. Construction of photodiode: it is basically normal PN junction diode with thin layer of P region and thick layer of N region, with a PN junction or depletion region between. The radiation is strikes on the anode side of the P region. It is coated with silicon nitride and inside a glass material so that more light energy is passed through it. The other sides are uh, painted black so that radiation do not falls apart. Overall unit is small in dimension of 2.5 millimeter about, and the current flowing through it is of microampere and is measured through an ammeter. Just a second. Yeah, it's got it. So material used to make photodiode can be silicon material. So the radiation for silicon material, the electromagnetic spectrum range constitute for 190 to 1100 nanometer. For germanium, it's about 400 to 1700 nanometer. And indium gallium arsenide material has 800 to 2600 nanometer of radiation of electromagnetic spectrum range. So the operational modes, there are two kind of operation mode. The basic one is photovoltaic mode, where the zero bias mode and no external reverse potential provided to the device. However, when the light is incident on the device, the minority carrier will flow and the current is produced. It is lower than the photoconductive mode, since in photoconductive mode we apply a reverse potential or external potential that increases size of depletion area, and more charge is produced and more current is produced. Working of photodiode: simple working of photodiode consists when photons strike the depletion area, the electrons starts to move, thus the holes start to move. If for a second, when we consider that there is no radiation in a photodiode, when a very small current flows through the device, that is termed as dark current. This dark current is the production due to minority charge carriers when the diode is not exposed to radiation. It is small and it is produced when the P side opposes the negative side terminal and N type opposes the positive side terminal. The small movement in electron and holes constitute for dark current. Now when the radiation is incident on the depletion layer, the excited electrons start to move from uh, sorry uh, at the two gets separated, then electrons from n side gets attracted towards the positive side of the battery, and holes get attracted towards the negative side of the battery, and thus higher current is produced due to incident radiation. And with the rise in light intensity, more electrons are produced and the current is increased. So The carriers are removed between the junction by inbuilt electric field of the depletion layer. The holes in the region moves towards anode and electron moves toward cathode, and a photocurrent will be generated. And as we know, the light intensity, when the light intensity increases, the photodiode will produce higher current. Now, solar cell. What is a solar cell? Solar cell is a photovoltaic cell or a PV cell as it is called, defined as an electric device that converts light energy into electrical energy through photovoltaic effect that I'll explain in next slide. Solar cell is basically a PN junction diode which on exposure to light produces electricity, and solar cell are form of photoelectric cell defined as a device whose electric characteristics such as current, voltage, resistance vary when exposed to light. Common single junction silicon solar cell can produce maximum of zero point 0.5 to zero point 0.6 volt, which is very low, and thus we combine the many solar cell to form a solar panel to produce considerable amount of renewable energy. Yet we know that solar panel cannot produce high amount of solar energy, thus solar farms are constructed. Principle behind solar cell is the photovoltaic effect, the generation of voltage across the PN junction in the semiconductor due to absorption of light radiation. So the process of production of electron due to strike of photon is known as photoelectric effect, and the process of production of electricity due to movement of electron which is caused by absorption of light radiation is known as photovoltaic effect, and solar cell works on the principle of photovoltaic effect. This is an example of how solar cell looks like, and this symbol represents a photovoltaic cell. So the types of solar cell are monocrystalline silicon cell, polycrystalline silicon cell, and amorphous silicon cell. And although monocrystalline silicon cell have highest efficiency when compared to other, its efficiency is yet very low when compared to practical uses. So the construction of solar cell is basically a junction diode with a thin P layer and a thick N-type layer. Photon is incident on the P-type layer, and it is absorbed in the depletion zone between the P-type and N-type. So it is little bit different from PN junction diode, but is very similar to it. Thin layer of P-type semiconductors grown on relatively thicker N-type, and then fewer electrodes are applied on P side and N side. The electrodes do not obstruct the light since we have given enough area for the radiation to be absorbed, and we also provide a current collecting electrode at the bottom of N-type layer, and thus the movement of electron constitute for the production of current. We encapsulate the entire assembly in a glass so that it can be protected from mechanical shock, and yet the radiation goes through the transparent glass. The upper surface is coated with anti-reflection coating so that there is no loss of incident energy due to reflection, and proper metal contact are made on N-type and P-type semiconductor for electrical connection. Material used in solar cell, material which are used should have a band gap of 1.5 electron volts, as they are semiconductor gap which can be used in diode. The silicon and gallium arsenide others can be used as an material for solar cell. The working of solar cell. So when light reaches the PN junction, the light photons can easily enter in junction through very thin P-type layer, and when the photon goes inside the diode, it produces electron hole pair since it breaks the thermal equilibrium condition of the junction. Free electrons in depletion region can quickly come to N side, the bottom one, and the holes in the depletion layer can quickly move towards the P side. Once the newly created free electrons come to N type and the holes goes towards the P type, they cannot further cross the layer because of barrier potential. And as the concentration of electron becomes higher on the side N type, and when higher construction concentration of holes on the P type, it will behave like a small battery because electrons and positive and negative voltage is produced, and this voltage produced is known as photovoltage. And when we add a some load or something like a bulb or something to this cell, uh, photo current will be produced and tiny current will be produced, but it will yet enough to make solar cell. Thank you for